welcome and thank you for coming to our presentation. Today we'd like to tell you about Summit Design and how we can help you dramatically improve your top-down design flow. After that, we'd like to show you with a brief demonstration of our new Visual HDL version 3.0. Now, we chose the name Summit for one simple reason. Our goal is to help put you on top of top-down design. Why? Because there's no view like the view from the top. It's the best place to size up your options and opportunities, the best place to plan your next steps. In 1994, we convinced many people that we could do just that. Our sales doubling from 7 to 14 million. We achieved much of this growth from the rapid acceptance of Visual HDL, our next generation design entry and verification solution. In its first 12 months on the market, we sold more than 600 copies, accounting for 6.5 million in worldwide sales. And to assure that our customers succeed, we've also developed an extensive network of sales and support offices in North America, in Europe, and the Far East. At Summit, the products we make complement your top-down design flow. We work to integrate your conceptual design work or system specifications with your top-down design process and eliminate some unnecessary design steps. Our flagship product, Visual HDL, provides a way to graphically capture and verify your design concepts and then generate efficient synthesis specifications automatically. Now, I know some of you are wondering if a graphical HDL tool can really improve productivity. Now, you may be thinking to yourself, I'm no great typist, but I'm doing just fine developing HDL code with my Emacs text editor. Well, why does my design group need graphical tools? Why? Because they're designed to think the way you're designed to think. In fact, designers have always thought graphically, even if their design tools didn't support it. Graphical top-down design is a real asset when you consider the way designers communicate. If you ask an engineer to go to the whiteboard, describe his next design, well, he probably won't start writing HDL code. More likely, he'll draw block diagrams or state diagrams to communicate the design's intent. Summit was the first to introduce graphical HDL design with Visual HDL. It gives you the power to express or communicate your design in a more intuitive way than just HDL code. With block diagrams and state diagrams, flowcharts, and truth tables, you can combine with HDL text. Visual HDL lets you express your concepts more naturally and debug them more productively. Now, specifically, how can Visual HDL help put you on top of top-down design? It improves design team communication and code reuse. It raises the productivity of design teams, especially those made up of both experts and new HDL designers. And with the help of graphical debugging, it lets you validate your HDL specifications more quickly. Well, let's begin with communication and code reuse. Now, here's a piece of HDL code. Okay, quick, Joseph, what does it do? I think we all agree what we have here is a failure to communicate. HDL code is great for getting information to a simulator or a synthesizer, but not from one person to the next. Graphics, on the other hand, communicate the design's intent and express HDL code faster and more easily. In fact, there's no comparison. You can either use a few graphic elements to express a concept and let Visual HDL manage your code, or you can use lines and lines and lines of HDL code. Graphical documentation also makes design reuse possible. Engineers sometimes document their code to help explain what's going on for later design reuse. Unfortunately, in most cases, they do this after the code is written, and the code and documentation seldom match. When you use visual HDL, your code is documented automatically, assuring that engineers who pick up your code later will have the documentation they need to reuse it. Today, very few engineers actually believe that HDL code alone enhances design reuse. And if you've ever inherited someone else's 20,000 lines of code without extensive documentation, well, you know how tough it is to understand it, let alone enhance it. But you'll likely find easier ways to recycle their code. So if communication or the lack of it is a problem for your design team, well, just listen to these designers from Storage Technology. They designed a fiber optic interface with visual HDL.
Visual has been very popular, and the reason being is, it seems to be very intuitive. People pick it up quickly. The implementers really like this tool. It's something they can get into, they can use.
It allowed Bill and I, with our vast experience, his view, everyone being not so a novice, it allowed us to communicate, because now we can do it graphically, we can do it visually, and I understood what he was talking about, or when the coder came in, I'd understand what he was talking about. And that made it a lot easier for us to work together and accomplish, get the same goal.
And I would say too, along the same lines, the really neat thing is being able to drive your actual design from your documentation. Which typically happens, people document things, and it starts to slide as you're doing the design. What's nice is to be always focusing back on that documentation. Everyone's agreeing, we've got the same source. Bang, all the design falls out of that. The code was great, it was readable. One problem I've had with tools like this in the past is sometimes you can't read the code. This code was very well documented.
Clear communication, self-documenting code, and great code generation of visual HDL. Sometimes it can make a world of difference. Now, as well as helping designers communicate better and enabling design reuse, visual HDL helps to raise your entire design team's productivity. The graphical embodiment of HDL languages, Visual, uses HDL for its database and every parameter. And rather than insulating you from the language, it helps you leverage it, letting experts use packages and as much HDL code as they want. Visual HDL also provides consistently high-quality code across the entire design team. By organizing code development, design management, and version control, by assuring more disciplined input, and by targeting code generation to specific synthesis tools. One company that's experienced this kind of dramatic productivity improvement firsthand is 3Com. They designed a 115,000 gate ASIC for an ATM switch using visual HDL.
The way we did things was first go jot down, just draw an idea, try it, simulate it, see what comes out of it, and then go back and change your graphical input until you're satisfied. Once we did it for the first time, we were able to continue to do it in that way. So as a matter of fact, we did not learn the HDL just by reading the books, but just trying it and see what happens. And the idea was we did not have to worry about redoing it later for synthesis. We were able to do it just one time right the first time. What the outcome of this approach was very positive. As a matter of fact, we have very few timing problems. We were able to slow down the process the clock, AC clock by doing highly parallel calculations. And we could concentrate on the algorithms, so we could concentrate on the high-level concepts of the design. We did not have to worry about synthesizing that code. We did not have to worry about all these issues of matching signals between components and processes and entities and architectures. This was all taken care of by the visual to concentrate on the work. From that to working with silicon, the path was very, very, very short. It was probably the first time we did not have to spend months on optimizing signal path and changing things. If we had problems, all we needed to do is go back to our graphics and change the design entry, and from that everything was automatic to low-level implementation.
Imagine a process that productive. Real customers, real designs with real success thanks to Visual HDL. Now perhaps Visual HDL's most valuable asset is its graphical debugging. With Visual HDL, bugs once concealed are now revealed. Tools like source-level debuggers and waveform displays are great when you work with sequential code, executing one line after another. But HDL was designed to model concurrency, and debugging concurrent code in a source-level debugger can be a nightmare. Visual HDL's debugging facilities were designed to handle these issues. Visual HDL provides simulation feedback in the design's original format, intuitively showing design status and indicating concurrent states. Its integrated simulator also provides more intuitive interfaces such as graphical breakpoints, interactive probes, smart probes, and backstage tracing. With Visual HDL, you can efficiently trace every signal in your design during simulation and bring up its history anytime you wish. If you want to know why a transition occurred, with Visual HDL's cause and effect feature, you just select the transition, click the cause button, and the system will tell you the exact line of code being executed at that point in time. Improved team communication and design reuse, higher productivity, and powerful debugging. These are 3 reasons why Visual HDL users are setting their sights on new productivity heights. But in today's fast-paced climate, even the market leader must get better constantly. And with this in mind, Summit is proud to introduce several new enhancements and products at this year's DAC. Heading our list is the 3rd generation of Visual HDL, giving you the most comprehensive list of product enhancements to date. 30 to 50 times improvement in our debugging speed, with incremental changes supported during simulation, and Swift model support. Superior design management with revision and access control. Open access to our database with a programmable interface and extension language. Full schematic design support to model analog or gate-level logic. And numerous other improvements to the graphic editors to better handle multiple levels of abstraction. In addition, version 3.0 supports every single synthesizer and HDL simulator on the market. We work with your synthesis vendor, and we have copies of their software in-house to tailor Visual HDL to work with the synthesis tool that works best for you. With Cadence, for example, we work closely in a joint project to combine the editors and debugging interface of Visual HDL with the ASIC simulation standard of Verilog XL to deliver Visual Verilog, the ultimate Verilog design environment. And to help Verilog test bench generation, we're also introducing Visual Test, which lets you use data move timing specifications to generate timing-based test benches. Combining TDS's WaveMaker timing specification tools with Visual HDL's graphical HDL entry, Visual Test lets you generate complete test benches, pre-screened for production test compatibility. Now we invite you to view a detailed demonstration of each of these products, and we think you'll see why we at Summit believe we're uniquely qualified to help put you on top of top-down design. Well, thank you so much for your time, and stay with us. Now I'd like to turn the presentation over to John, and he will be giving you a quick 5-minute demonstration of Visual HDL 3.0. And when he is finished, please come up for a blue ticket you'll need to receive a free t-shirt at our literature stand on the other side of the booth. John?
Good afternoon. I'd like to take you through a quick presentation or demonstration of our Visual HDL product. This is our 3.0 release, and this is our top-down design environment for VHDL designers. Our Visual Verilog product is being shown in the demo pod over to the left, and that's the same environment but for the Verilog designer. I'm going to start off by bringing up the design browser so we can take a look at some of the design management capabilities of the tool. Here you can see that we have a number of different libraries currently installed on the system. Each library could represent the work of an individual engineer or project, or perhaps models received from some other third-party vendor. For example, here you can see the packages that would have been supplied using the IEEE package. Let's go ahead and open up our board library, and we'll take a look at the contents. All of the data that we generate within Visual HDL is stored in one of these logical libraries. And here you can see some of the different units that we currently have in the library. We have several VHDL models. We have a number of different block diagrams and several state machine designs. A new feature in our 3.0 release is the ability for each of these individual objects to be under source code control, so we can check in and check out each of the libraries and maintain a history of our entire design changes. Using our project manager, we can set up an individual project that would be using a certain revision or configuration of our design units. Let's go ahead and take a look at our board design. And what we'll see here now is a hierarchical representation of the design. So for example, we'll be able to see that we have the board design at the top, and we can see a little bit of the hierarchy and the structure of the design that we're currently working on. It's composed of many different elements, including block diagrams, flowcharts, and state machines. Well, to give you an idea about what it looks like to work in the visual environment, I'm going to go ahead and invoke a small script that will bring up several visual windows for us. Our scripting language is a new feature of 3.0 and is based off the CFI scheme standard. So let's go ahead and load that up real quick.
Me get somebody to.
And this will enable me to show you some of the different editors and features within the design environment of Visual. The first diagram that we're going to bring up is an example of a block diagram, which represents the top level of our design. And each of the blocks here is represented by a different type of component. For example, we have a state machine design inside of here. We have some flowcharts that are used to describe a portion of the design. We also have an algorithmic state machine. Additionally, we have VHDL text, a model that would have been imported through our entity, as a complete entity and architecture. In addition, we can instantiate just VHDL code fragments directly in the model. Also, with the 3.0 release, we have the ability to use LMC smart models as part of our design database. The other editor we have available is called Truth Table Editor, which gives you a spreadsheet-type capability for capturing your design functionality. You can enumerate out the values of the inputs, which are shown here in the blue, and then set the outputs to the corresponding values. This is a very straightforward and simple way of capturing combinatorial logic. The next editor that we're going to take a look at is the flowchart editor. Flowcharts are very good for doing behavioral descriptions and also for doing algorithmic state machine descriptions. Here we can see the flowchart specifying the control path through the design. Each of the blocks here would have, again, VHDL or Verilog syntax behind them to describe the functionality of what should occur within each component. The state machine editor in Visual HDL is based on a bubble diagram editor. Each of the individual states are represented by a separate bubble. We show the possible transitions that can occur from state to state using the different arcs. Each arc is also controlled by a guard expression that tells us when that could be a valid transition, and the syntax again is VHDL or Verilog for that. We also support hierarchical state machines and concurrent state machines on the same machine. We do have the ability to import in VHDL text directly. Here you can see a particular architecture that we're using. And this enables us to use legacy data from the previous design. You can instantiate it onto a block diagram, or perhaps you still have an engineer who would want to work in the Emacs or VI environment, where you can import the code into the digital environment and continue to allow that to be used as part of the design. The next step that we'd like to do here is to invoke the simulator, so we can see a little bit about the simulation and debugging environment. First of all, we brought the control panel up. We have the waveform display. You can see several of the different signals we're going to trace. And we've also set a number of different breakpoints in our system, so we can actually halt the simulator and then interactively single step through the design. Here we have 4 different breakpoints that are set. So let's go ahead and start running our simulation. And you'll start seeing the simulation time move forward, the waveforms will get updated, and when we hit a particular breakpoint, the module in which that breakpoint occurs will be brought to the front of the screen and the breakpoint highlighted. So here's the example in the VHDL model, and at this point now we can start to single step through the code, examining each of the individual signals or variables that may exist inside this particular VHDL model. Let's go ahead and continue with the simulation. And as we move forward, we'll then hit the next breakpoint in our design. And this one is going to occur, I believe, in a flowchart. There we go. Now, within the flowchart, we have a particular element that is highlighted, and we now have the ability to single step from block to block. At any particular point, we can also push down into an underlying block and see the code that's being executed underneath. In this particular case here, we can see a particular line that's being executed in that block. Okay, let's go ahead and continue with our simulation. And as we move forward here, we're going to execute a breakpoint that's going to occur within one of our state diagrams. You'll notice here that the current state, the idle state, is highlighted, and we're currently evaluating coming out of the state on this particular arc and moving into our junction block. If we single step through the model, we'll be able to see which particular port is being executed out of the junction. As we continue to single step, we'll see that we move into the major vote state. We can continue again to single step through here, pushing down into underlying levels of the state machine or individual arcs. In addition to being able, another feature of the visual product is what we call our cause and effect capability. We have the ability that we can identify a particular transition in our waveforms, and we can ask the question, why did this occur? Well, by hitting this pause button up here, it will bring up to the front of the screen the particular module in which that transition was scheduled from. So as an example here, we can see that that transition occurred within a block in our flow diagram, and then here's the particular line that was executed that caused it to happen. In addition to performing simulation analysis, we also have the ability to go in and profile and look at different characteristics of our designs. As an example, we can look for unreached states in the state machine, or we can look for undriven signals that might exist inside the design. We also have the ability to profile and look at the different activity levels within the circuit. So for our flowchart, we go ahead and hit the OK. We'll see a histogram that shows us the amount of activity that occurred within that particular design. Once we've completed as a design and we're ready to move forward into the synthesis environment, the Visual HDL product gives us the capability for generating either a full VHDL or a Verilog description of our design and targeting that description towards a particular synthesis tool. So by selecting a synthesis and identifying the vendor, we can ensure that the code that's coming out of our tool is going to be compatible with the style restrictions placed on you by the synthesis tool. This also guarantees that the code that we've generated will be optimized for that tool to guarantee that we get optimal results at the gate level from the synthesis. So that's a brief overview of our product, the Visual HDL. I encourage you to get a more in-depth demonstration, and we'll be passing out the tickets or the t-shirts. Thank you.
These are 3 reasons why Visual HDL users are setting the sights on a new